All right, we're going to do GCF and LCM practice today. So number one, which of the following has the greatest number of integer factors other than 1 in itself? All you have to do on this, we're not going to do any kind of prime factorization, you're just factors. So remember this from elementary school. I guess not elementary, maybe middle. So 12, I would do 1 times 12 is 12. Then I would jump in. Okay, 2 goes into 12 6 times, so 2 times 6. And 3 goes into 12 4 times. There's no other numbers, so then I'm just going to count. Oh, I'm sorry, other than 1 in itself. So we're not going to include these, and then we'll count. 1, 2, 3, 4. So there are 4 integer numbers. Going down, 1 in 16, again, we're not going to use, so 2 times 8. And then the next set is just 4 times 4, but we don't write 4 twice, so we just write it once. So 1, 2, 3. So right now B is out because 12 has more. 29 is prime, so we should go ahead and just cross that one out. We can't have 1 in itself, which means no prime numbers. 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So 1, 2, 3, 4, 5, 6. And for 27, 1 times 27, and then just 3 times 9. So it only has 2, making C the value that has the most integer factors other than 1 in itself. Okay, number 2. So on number 2, all we're doing here is we're trying to figure out numbers that are greater for y. So automatically k is out, and so is 0, because the value has to be greater than 0. Anytime you have these factors equal to 0, you can just set each individual piece equal to 0. Not gonna lie, when I did this the first time, I distributed it and did factor by grouping just to end up exactly where I started. So anytime you have this, you can just set each piece equal to 0. So I get y equals -2, which is wrong. I want values greater than 0. So this I'm gonna add 2, so get 5y equals 2. Divide by 5, and I get 2/5, which is answer H. Number 3, which of the following is not equal to the other 4? All I would do is type it in your calculator. So 1.1 times 10 is 11. 110 as a decimal, you would move the decimal point to the left twice, so 1, 2. I get 1.1. The square root of 1.21 is 1.1. So right here, I see that these two are equal. I'm looking for the one that's not equal. So obviously it's A. I could continue. 11 divided by 10 is 1.1. And then 1 plus 1 over 10 is also 1.1. So as soon as you have repetition right here, you actually don't need to finish the problem because you know that everything should equal 1.1. And the one that doesn't is option A. Okay, if x is equal to 4 is a solution of the equation x squared plus kx minus 24 equals 0, what is the value of k? Now, we have not really talked about factoring, but you don't have to factor to be able to do this problem. So x is equal to 4. So 4 squared plus k times 4 minus 24 equals 0. 4 squared is 16. 4 times k is just 4k. Minus 24 is 0. Combining here, I would get 4k minus 8 equals 0. Adding 8 would give me positive 8 on this side. And then dividing by 4, k equals 2. So, you're good. That's all you have to do. You don't actually have to factor this. It might look like you might want to because you have an x squared and an x and then a constant, but you don't have to. All you have to do is substitute and solve. So k is 2. Number 5. The sum of the squares of 2 consecutive positive integers is 244. The 2 integers are blank. Just test them. So sum of the squares just mean I'm going to square 4 and add it to 6 squared. Well, I get 52 when I do that. 52 does not equal 244, so it's out. That's all you have to do. You don't have to do anything hard. So jumping down to k, 10 squared plus 12 squared is equal 244. 100 plus 144 is 244. So it is true. So the answer is J. All you have to do is square them and then add them together. Evaluate 6 factorial. This is a great problem. Remember, a factorial is where you take this number, so 6, and then you multiply it by every number after it, stopping at 1. So you could do it the long way. You could do 6 times 5 times 4 times 3 times 2 times 1 and get 720. Or you can do it in your calculator. Let me find mine. So I can go right here and go 6, press math, and go over to probability. Option, oh my goodness, hold on. Math, over to probability. Option 4 is the factorial. So 6 factorial, 720. So even though you don't need a calculator to do all of the questions on the ACT, it's a whole lot faster if you have one. All right, how many prime numbers are between 20 and 30? Now this is not prime factorization, it's just us counting prime numbers. So we'll start 21, not prime. 22, not prime. 23 is prime. Then we've got 24, that's even, so it's out. 25, that's not prime, that's 5 times 5. 26, again, even numbers are out. 27 is actually 9 times 3. So 27 is also out. Moving up to 28, that's even. Then we have 29, and 29 is in fact prime. And we don't count 30 and we don't count 20. And plus, those are composite numbers anyway. So just 23 and 29, so the correct answer is B, 2. What are the positive factors of 1 and 64? That is exactly like problem number 1. Okay, exactly like problem number 1, where we break down our factors. So I'm just going to look, okay, 1 times 64. Well, it's not a prime number, so it's going to have more factors than just 1 and 64. It's definitely not all of the above because I know that A is wrong. So I'm just going to go through and check my answers. So looking, I have 1 times 64. That's true. 2 times 32. That's true. 4 times 16. That's true. Pretty sure. Let me double check. Now that I'm saying these values, let me make sure. 4 times 16, that is 64. And then you move into 6 times 12. 6 times 12 right here is 72. So D is out. So if we were to cross these out because they're not true, we would get answer choice C. So it is C. That's all you have to do. Just build your factors just like we did in problem number 1. All right, number 9 is prime factorization. Notice how it has the big solid dots. All you're going to do is break up 72. So 72 is 2 times 36. Remember, if you're stuck, you can always just start dividing even numbers by 2. Can't break up 2, but I can break up 36 into 2 times 18, or 6 and 6. 18, I'm going to break into 2 times 9. I can break 9 into 3 times 3. So now I'm just going to put it together. I have a 3 and a 3, which represents a 3 squared. Then I have 3 2's, which would be 2 cubed, which is represented in E. So just be careful. This is saying that it's prime, like that's totally wrong. These are not prime numbers, not prime number, okay? So if it includes not a prime number, it's not in a prime factorization. And then this one, they were just trying to trip you up with the numbers. Okay, number 10. All right, number 10. Scroll up here. If 4 times 3 raised to the x is divisible by only 9 integers, then x equals blank. Okay, all we're representing here is that these values are the representation of x. So I'm going to just do 4 times 3 to the 1. Well, 3 to the 1 is 3, times 4 is 12. I'm looking for 9 possible factors. Well, there's not 9 factors of 12. You get 1 and 12, 2 and 6, and 3 and 4. Notice how we always have even counterparts. 1 and 2, 1 and 12, 2 and 6, 3 and 4. 1, 2, 3, 4, 5, 6. For there to just be 9 integers, which is an odd number, that means that there's no pairs. Not everything has a pair. So the one in the middle, we're going to be looking for a perfect square. Because for there to be an uneven amount of factors, it has to be a perfect square. Well, looking at our answer choices here, okay, when I start to simplify, we should notice that we're not getting very many perfect squares. So looking at 12, we see that we have, we see that we have 12, which is not perfect. So now I'm going to try 2. 4 times 3 to the 2. 3 squared is 9. 9 times 4 is 36. Okay? Well, 36, that's a good sign. It's a perfect square. Now let's simplify. I'm going to break 36 into 1 and 36. Then I have 2 times 18. 3 times 12. 4 times 9, and then 6 times 6, which we just write once. 1, 2, 3, 4, 5, 6, 7, 8, 9. The correct answer is B. Number 11, evaluate 3n all raised to the factorial. First thing you got to do is substitute. So 3 times 2 to the factorial. Now 3 times 2 is 6. So again, now I have 6 factorial. You have seen 6 factorial over and over and over. It's because they like to repeat their answers. So 6 factorial is 720. Okay. Number 12, you can do one of two things. The first thing I would recommend is if you're unsure of how to simplify perfect squares, we haven't gone over it yet. I put this on here so you can test your calculator skills. I'm going to first simplify the radical. So if you're comfortable with simplifying the radical, what that means is you're looking for a perfect square times a number. Well, 36 times 2 is 72. The square root of 36 is 6. The square root of 2 is unsimplifiable. So it is E. You can do it that way. Or let's say that you totally don't know how to do any of these. It's okay. Okay, no one's going to judge you by picking up your calculator and saying, okay, square root of 72 is about 8.4. I'm just going to test my answers. Okay, that one's technically correct. Let's test this one. Okay, that one's definitely out. Okay, notice how I'm not picking the first answer I see. Okay, that's also the same. That one is not the same. Okay, I've narrowed it down here to 3 potential answers, okay? When you are simplifying radicals, look underneath. Look for perfect squares. I can simplify this 18 by breaking it up into the square root of 9 times the square root of 2, which would simplify to 3 root 2. 18, the square root of 18 can be simplified more. So this is not in simplest terms. The 8, I can break that up into the square root of 4 times the square root of 2. Square root of 4 is 2 root 2. Again, that can be simplified more. There is no perfect square hiding into making it E. Okay, this is a hard problem because we haven't covered it again in class, but you have learned it before. All right, next one. Which one of these is an irrational number? So the thing we have to remember about irrational numbers is that irrational numbers continue forever and never repeat. So the square root of 16 is just 4. That's a rational number. Square root of 25 is 5, so this becomes 3 times 5, which is just 15. That's out. Remember, you can break up this square root, so this becomes technically the square root of 4 over the square root of 9. Square root of 4 is 2 over 3. Okay? Next, this we'll skip to E, because D is technically the correct answer. Notice how these are separate. They might look, you might be like, oh, that's not a perfect square. We got square root of 3. You can also put it like this, 3 over 27, which reduces to 1 over 9. And now when you re-break it up, you get an answer of a third. So E is out. It's tricky. They're purposely trying to trick you because you see the square root of 3 and you're like, oh, that's an irrational number. Be careful. The correct answer is D. What is the least common multiple of 70, 60, and 50? All you have to do is divide 70, 60, and 50 into your answer choices. So I'm going to zoom out just a little. 60 is not divisible by 50, 60, and 70, so these are out. Okay? Then I'm going to do 180 divided by 60. I get an even number. That's good. 180 divided by 70. Decimal, out. Continue. 210 divided by 70 is 3. 210 divided by 60. 3.5. Out. As soon as you get a decimal, it's out. Remember, least common multiples can't be decimals. So 2100 divided by 70 is 30. Dividing that same number by 60 is 35. And we should know that 50 goes into that. So we also get 42. So those are all whole numbers. So J is my answer because I want the smallest multiple. All right, for 2 consecutive integers, the result of adding the smaller integer and triple the larger integer is 79. What are the 2 integers? So in this case, we start out our number line at x. Like x would represent the first integer. If I want to get to the next integer, my next integer, I would take where I started and add 1. So our first integer is represented by x. Let's say it's 1. To get to the next integer, which is 2, 1 plus 1 is 2. Okay? Consecutive, you add 1. All right, so the first integer is x, and we're looking for adding the smaller and triple the larger is 79. Now you could do guess and check on this. It would work the same. Or you can just make an equation and solve. So I have x plus 3x plus 3 equals 79. So I get 4x plus 3 equals 79. Subtract 3, 4x equals 76. 76 divided by 4 is 19. So x is 19. Now, x represents my smaller integer, which means my consecutive one would be 20. It's not a. X is the smaller of the 2. Again, you could do guess and check. You could do 19 plus 3 times 20 to get 79. You can do it that way. This is how you would use an equation. All right, what is the unit digit of 5 to the 27? So this is a little tricky. What I would recommend is just testing some answer choices. So if I raise 5 to the 1, I get 5. If I raise 5 to the 2, I get 25. If I raise 5 to the 3, I get 125. 5 to the 4. Do we notice the pattern? The units digit is the ones place. So notice how all of these are 5. I'm pretty sure the trend here is going to be 5. So my correct answer is 5. That's all you have to do. You don't have to do, what happens is it gives you this error. Okay, that's why they put this problem on here. Hopefully you're noticing patterns, and it obviously ends in 5. Okay, this is a prime factorization. So this right here is a prime factorization. They want you to unprime factorization it, okay? So all that means is you're just multiplying 4 to the 3 times, because remember, this still means multiply, 3 squared times 2 to the 3, 4,608, which is option E. That's all you have to do. Very basic, it's all calculator. What is the prime factorization of 144? Hopefully you have learned that 144 is even, so it is not prime. 36 is not simplified. 4 and 9 are not simplified. So just with that knowledge, we narrow it down to 50-50. You can do one of two things. You could test your answer choices by multiplying them together, or you could do the prime factorization. So I'm going to do the prime factorization real fast. You can choose to do whatever you want, okay? You can type this in just like we did up above, or you can just do the prime factorization, whatever is faster. So I see 3, I have 1, 2 3s, so right here, we know our answer is D. That's all you have to do. Okay, 19, evaluate 6 factorial over 3 factorial times 5 factorial. Totally can do this in your calculator. So I'm going to go over to probability, close parenthesis, divided by 3 probability times 5. Oh, nope. There we go. Close parentheses. We get 1. That's all you have to do. It's a basic calculator question. Remember, you can do all this without a calculator, but factorials are really a pain to do without, so I would just stick with doing them with a calculator. Very last one, what is the prime factorization of 210? Again, I hope we can realize that 21 can be broken up into 7 times 3. So A is out. 105 can be 5 times something, so this is out. So we are left with these 3 values. So let's go ahead and break it up. So I'm going to break it up into 2 because I notice it's even, so 2 times 105. And then I know 105 is 5 times something, and it's 5 times 21. But 70, oh, what am I thinking? I was looking at the key at the same time, but at the wrong problem. 70 is not here. So 21 is 3 times 7. So I should have a 2 in my answer. This does not have a 2. It's out. I should have a 5 in my answer. This does not have 5, so it is out. So it's really just 2 times 3 times 5 times 7, which is option C.